Here we are at example 5 from our 2.4, number 2 set of notes. We're supposed to write an equation of a line that's going through this point T, so this guy right here, that is perpendicular to AL, that segment. Now, anytime we have these 2 points, AL, we can go ahead and find the slope of these 2 points. So if we go ahead and find that, we end up then with M is equal to, we'll call this one X1, Y1. This guy will say he's X2, Y2. So our slope is our y2 minus our y1, which is 7 minus 5 over our x2 minus x1. So it looks like 6 minus 2. So then it looks like our slope just comes out to be 7 minus 5 is 2 over 6 minus 2 is 4. Simplifying that just comes down to be a half if you divide the top and bottom both by 2. So our slope between A and L comes out to be a half. Now, it says we're supposed to write an equation of a line passing through T, but is also perpendicular to this segment AL. Well, we found the slope of AL, and if we wanted something to be parallel, it would be the same slope. But here it's specifically saying we want it to be perpendicular to AL. And as a result, we have the slope, it's a half. We then have to find the perpendicular of this slope AL. So to find the perpendicular of that, we have to take the opposite reciprocal slope. So the opposite of a half comes out to be negative 1/2. And then the reciprocal, all you have to do is basically flip the numbers on top and bottom. We then end up with negative 2 over 1, which basically just simplifies out to be negative 2. So we're actually going to go ahead and use negative 2 as our slope, because again, that is perpendicular to the slope AL. Now we can go ahead, and since we know the slope, we know it's passing through this point T, we can go ahead and write the point slope. So we have y minus y1 is equal to m times x minus x1. And again, we can do this because we have our point and we have the slope that we're going to use. So we then end up with y minus our y1 is negative 1 equals our slope, here he is, negative 2 that we're going to use, times x minus our x1, 8. And from here, it's pretty much just simplifying things. So the opposite of negative 1, really we're adding that one. So we end up with y plus 1 is equal to, distributing the negative 2 on the right side, we end up with negative 2x plus 16. And then lastly, just subtracting that 1 over. When we do that, we end up with negative 2x plus 15. So here is our equation that, notice, is passing through this point T and would be perpendicular to this segment AL. In other words, if we are going through this point and it is perpendicular to AL, we should end up with that right angle there, making then this slope and the AL slope perpendicular with one another. So again, though, that is example 5 from our 2.4 number 2 set of notes.